नाही तर जोशी मामांना बोलून
Mustafa sir, then recently Kulkarni sir, right? So I will just add some more things to your knowledge if I can, and I'll try my best to do that. Okay, so something like say battery technologies for electric vehicle application. Nowadays everyone is aware of the scenario. Now our friend has mentioned that he owns electric vehicle, right? Eventually I also ride electric scooter, if not car. Right. So it's good scenario at the moment because of, say, it is pocket friendly now. So why it is pocket friendly? We can talk in that commercial terms also. But at the same time, we will also highlight.
लाऊड इज इट ऑन दॅट इज ऑन दॅट इज ऑन इथे फक्त काहीतरी त्यांना मामांना बोल आवाज आवाज
Okay. Is that audible to last voice, sir?
इज इट ऑडिबल
So let's go ahead. I try to raise my voice.
गंगाधर ऑडिबल आहे
Okay. So thing is like we'll try to highlight some of the importances of these battery technologies and for you as youngsters. So I mean, charging something, yes, it is happening. You can see many green plates on every road that we are moving, right? But is there something that I can contribute? Just let's throw this question to you. With this question, is there anything for me to contribute? Just keep that question alive. Okay? So let's try to answer that question in my session today, right? And if that is something is there for you, that will be great. Okay. So this is also
yeah I think we should go by
okay. So my alma mater, where I belong, you are all aware. It's a 450-acre green lush campus. I'll request all of you to visit the campus now. It's very nice, very pleasant, very similar to yours one, except the age group is different. The occupants and like the personnel working there. Okay, so yes, it's nice campus, and I belong to Center for Energy Studies. We have Tech Energy Technologies. If you are from basic science degree or postgraduate degree courses, you do not have direct entry for our Tech Energy Technology course. But if there is a friend or brother, sister or colleague, if they want to pursue their career in energy technology, it's a good course actually. And at the moment, maybe we call for an application, although it is closed at the moment, it will be reopening that call once these PE results are announced. Okay, so with this small introduction, we have other than that for you people, what we have, if you are a master student, we welcome you to visit our laboratory, and as a part of your master's project, maybe we can host a couple of new people at our laboratory for pursuing your project, master's project. Okay, so agenda is not too heavy, just 3-4 lines. Yeah, okay, so I am going to hear. Okay, so we talk about electric vehicle. Vehicle comes under the mobility, right? So why do we need electric mobilities? Any question or any answer? Wrong answer. Any answer is okay. Pocket friendly was good answer. Other?
Nature friendly.
Range is just one more another. Okay, so nowadays what we have in petrol stations, dispensing station, we go and pump our fuel into this. But nowadays for 2-wheelers, 3-wheelers, they are coming up with very similar kind of scenario. So a people battery stopping policy, itself already in place, and that will something else was mentioned.
Nature friendly.
Nature friendly. That's a good question. That's where we all started. The main drive to push the electric vehicles. Although those were not pocket friendly, as I pointed at the moment, those were not pocket friendly. Their costs have been brought down with maybe economies of scale or something else, right? So that was something. And And not to forget, we have to care the environment. We are committed to sustainable development goals, right? So you must be not, if you are not aware, because everyone on this planet Earth has to align to sustainable development goals. We have 17 sustainable goals, and all of us must try to contribute in some form or other. Okay. So there is certainly a link between transport sector and carbon dioxide emission. Why? We are certainly facing that, because somewhere between 45 rupees, maybe 5 years, 10 years time down the line, but at the moment we are paying 100 and we paid 115 rupees per liter at some point of time. Now, although it is reduced for a while, right? So it's not pocket friendly. At the same time, every kilogram of petroleum fuel will emit 1 kilogram of carbon dioxide, at least. I mean, very close to, right? Okay, so I mean, the numbers can be some little bit here. Just please forgive me. Why? Because when to be speaking, scientifically speaking, that has different meaning. Okay, nonetheless, it emits, right? Even for the electricity that we are using for the display, the fans, the luminaries, or projector, or whatever devices that we are talking about, they are using electricity, but it is generated in 61% of electricity being generated from coal. Again, very bad, because burning how much coal gives you 1 kilowatt hours of energy? Now it's exercise. Okay. Carbon, you have to contribute, right? At least gather knowledge and synthesize for gather data and synthesize for knowledge, right? Okay, so car in Pune we certainly face. Of course, Pune is a two-wheeler city, but cars also very much in number. We can go to some website of transport authority and we can get these numbers. Right? We have to switch to very much green mobility, right? Now I am making very abrupt transition to classify the type of electric vehicles. Now I have not added anything out of your internal combustion engine, IC engine car. How much is their efficiency, by the way? Basic parameters are thermocycle efficiency, ICE thermocycle, upper limit of thermocycle efficiency.
Current cycle efficiency is 100%.
In terms of power, stroke
Around 40%.
ठीक है बघा त्यांनी मला ऑलरेडी 100% ऑलरेडी बाकीचे नीट आपण काय करायचं already it is sitting up on there, right? Oh, so that 38% or and we eventually get much more less than that, right? But we are not talking about that. We are talking about the electric vehicle cars who are having efficiency of 75 to 85%. Right? It's good news, right? So we have much efficient kind of technology eventually, right? So instead of burning some fuel and using at much lower efficiency, using these fuels is very much good for us, for our efficiency factor, right? So we have at least 4 types of your electric vehicles. First, battery-based electric vehicles. Then we have hybrid type of electric vehicles. What kind of hybrid? The hybrid of internal combustion engine and the electric vehicle, right? So it has 2 kinds of drivetrain, maybe in some cases either of them, right? Then first is hybrid electric vehicle, then second plug-in hybrid electric vehicle. Plug-in means it also has facility to have connection or the charging from the fuel cell based electric vehicles. What is fuel cell? You must know, right? How much, what, Professor Kai, how does it work? Fuel cell. Okay, homework technology. Okay, after you understand, we have hydrogen, we have oxygen. It's a controlled kind of reaction that you are conducting. Product is water, hydrogen plus oxygen is water, and at the same time we get electricity. So it has some setup. Okay, so it's a fuel cell. The output is electricity and the byproduct is water, right? So that's how electricity is generated, and that electricity is now very much similar to your first type of electric, right? Beyond that, after generation of electricity, right? Okay, so these are two types of electric vehicles. Now, looking at the simplicity or complexity, so it's like what are components? This is battery based, it's a pure electric vehicle. Here we have battery packs, the charging facility, the battery packs, then electric motor and the drivetrain, which is connected to your wheels, right? That's it. Very simple. Okay, so I don't have picture, but you must have seen how much is the complexity when we have a car with internal combustion engine. If you open the bonnet, you will find that there are at least 350 wires, maybe some tubings, maybe something else, maybe some connection, maybe some electrical connection. All these are 350 connections and moving parts. So here how many? Very less in number, something like 35 to 38. The whole vehicle itself. These are the very less number of moving parts. Okay, so although this is not main part of our discussion, so I will just give you idea of that. So this is readily available to you. But okay, so hybrid vehicle, we have fuel tank, meaning very similar to your internal combustion engine car. We have fuel tank. So we have fuel tank like your IC engine. Then we have internal combustion engine and the drivetrain. And another branch is your electric vehicle branch. Right? So battery, the electric motor, and the drivetrain. Right? Okay. So fuel cell very similar to your instead of your fuel, say I'm sorry. This is again it's not fuel cell. This is again plug-in hybrid vehicle. Here the battery is charged by the engine itself. Engine generates runs your dynamo, turbine, whatever you call. Then it's storing power in the battery system, right? And then we can use it whenever we require. So here we will run our engine at the optimal efficiency. Instead of, for example, if it is a fuel, our internal combustion engines do come under tremendous load, so that they are not working at the optimal efficiency. But instead of that, we will run our internal combustion engines at optimal efficiency, and we will generate electricity, and that will be used for your running of your vehicle. Here, the third vehicle, for example, these are some components of it. So you can know from the complex, from the components itself, you can know the complexity. And fuel cell based electric vehicles, the thing that we just now discussed. Yeah. So this is the advertisement now. The pocket friendly, right? I don't know whether it is at the moment, but it is there. So what is termed for as cost of ownership, total cost of ownership. Meaning, so if you pay, for example, let's talk about maybe Tata Nexon, right? So if it is internal combustion engine based car, it will cost something. For example, I'm just saying just random numbers. If it is 15 lakh rupees, but to run every 10,000 kilometers, you will have to spend something more on two types of fuel. Either you prefer it as an internal combustion engine, or you prefer it as an electric vehicle. To run 10,000, next 10,000 kilometers, the cost will be something, right? So, effective cost of ownership of your internal combustion engine goes on increasing, right? But for your electric vehicles, since how much is the typical size, we are going to see that something like 40 kilowatt hours. 40 units will be required to charge from 0 to 100% of its charge state. 40 units, how much is the cost typically? Let's say 10 rupees per kilowatt hour, 10 rupees per unit, 400 rupees. For 10, multiplied by 4, 1600 rupees for full range of your vehicle. For the same range, fuel cost certainly more than that for your internal combustion engine, right? So that's very much understandable. Now, so here is typical. So how it is evolving? The evolution is happening already. There is a comparison between these two types of electric vehicles. First is plug-in hybrid electric vehicles, meaning we have charging facility. At the same time, we also have internal combustion engine. And the second, the black ones are the pure electric vehicle. That time we do not have any additional source of energy. Here, it's completely running on the battery power. That time, the average battery pack size is evolving, meaning it is increasing. Maybe you already heard, Tata Nexon is a good example of selling of your electric vehicles at the moment, right? Earlier they had a range of 240 kilometers or something, 250 kilometers, 280 kilometers, depending on the driving pattern and the road conditions. Okay, let's say 250 kilometers. But recently they have announced something else, which will give us the range of almost 500, 480 or 500 kilometers, right? So what is that indicating? As the efficiency increase? No. The battery bank size has increased, right? So that's how it is evolving. So average size of your, I'm sorry, the y-axis region is not readable, but the average battery capacity per vehicle, right? So earlier it was 41, 43, and it is projected that it will be 35. The average battery bank size will be 45 kilowatt hours. You will be able to store 45 kilowatt hours. Kilowatt hour, it's energy, right? Okay. So what is this picture? This is a picture of some battery pack of a car. Okay, so it's just advertisement, some pictures. We need not revisit these parameters, right? Very good. Let's revisit. So what is potential or voltage? If you take multimeter, put your two leads on two ends of your cell, the observed voltage is nothing but potential. That is open circuit potential. To be precise. Current, if you have a load connected to those two terminals, then there will be some flow of current. That current can be measured, right? So what will be deciding the current? Two parameters. First, the battery limitation itself, and second, the load itself, right? Now we have to have some communication, right? Power. Okay, obviously, what is power, by the way? Current times voltage. Electrical power, right? It's a DC system, purely DC system, right? Current times voltage. Now capacity. Capacity is always taught for cells or batteries in terms of ampere hours, right? What is ampere hours? These many amperes for those many hours, for 1 hour, something like that. कन्फ्युजन आहे का? आपण बघू आपण थोडंसं पुढे गेलं ना पॉझिटिव्ह विल बी एबल टू टॉक अबाउट दॅट. ओके, सो देयर इज सम मोर. Cell is one unit of your, for example, sir has shown one cylindrical unit that was a cell. But nowadays, तुमचा मोबाईल बघा ना, तुमच्या मोबाईलमध्ये काय असते? सेल असते का बॅटरी असते? मी कसं काम करतो बॅटरी? त्याचं व्होल्टेज तर 3.7 व्होल्ट असते. कारण लिथियम आयनचे व्होल्टेज आहे एका सेलचं व्होल्टेज तेवढंच आहे. Right? So this is now intermixed terminology, right? So let us use battery as a common terminology, right? So there is no confusion. Now we are going to study that as your battery, right? So if you make a series connection, this is 1 unit called as cell. If you make that a series connection, right? So 4 cells in series, what will happen? Individual cell capacity is 3.6 volts and 3400 milliampere hours. म्हणजे काय? 3.4 ampere hours. Correct? So if that is this capacity of individual cell, we have 4 such cells connected in series circuit. काय होईल? Voltage will be added. Current will be the same as that of individual cell. Right? What if they are connected in parallel? Voltage will be the same, whereas current will be parallel. Okay. Let's talk about capacity of battery. That dual radio, because I just now mentioned your battery of your cell phone, mobile phone. How much is the capacity? पर्सनॅलिटी किंवा त्याच्यावर किंवा तुमच्या मोबाईलवर गुगलला विचारा म्हणजे बॅटरीचे स्पेसिफिकेशन काय 5000 milliamperes. Voltage 3.6 or 3.7, right? I mean depends with what kind of little variation in chemistry, right? Good. So you know many of them, right? So typical voltage is 3.7 volt. Typical capacity is 5 ampere hours, right? Therefore, how much is the energy storage capacity? 18.5 ampere hours. This is capacity, right? Alag. So the term that I have used in the previous slide is already known. So this is age capacity. Or what are capacity at the moment? AH is energy. 5 AH is your capacity. If you multiply that with voltage, it will be power. Right? So, ampere hours is capacity. So, how much is the energy storage capacity? Energy storage capacity, not just rated capacity. What we have, right? So it will be 18.5 watt hours. Battery used for your household UPS. You have lead acid battery. Voltage is 12 volt. Why? Lead acid is not typical battery. Why? Because there are 6 cells connected in series. Okay. Individual cell voltage is 2 volt. But let's assume, I mean you know it, and the voltage is 12 volt, capacity is 200 Ah. How much is the energy storage capacity? 2.4 kilowatt hours. Alright. So let us correlate this with how much is the energy storage. I just now mentioned in previous slide that we need 40 kilowatt hours. So that is the typical storage capacity at the moment, right? So how much is the required? Who decides it, right? It is known that in city driving conditions, the average electrical consumption is 33 watt hours kilometer for three-wheeler, and for typical four-wheeler, it is 123 watt hours per kilometer. And so it's low power, high power four-wheeler something, right? So it's known to us. This is actually, I have cited it from this paper. You can cross-refer it. Now, for highway driving condition, the average electrical consumption is 165 watt hours for high power four-wheeler. Right. Okay. So in high power, so to compare, let's say maybe Mahindra Evo, right? So it's a low power electric four-wheeler, and we have Tata Nexon, for example, or ZSEV, whatever. Those are high power electrical four-wheelers, EVs. Therefore, to drive 500 kilometers of four-wheeler, we need 165. These are watt hours per kilometer. Multiplied, so 165 multiplied by 500. So we need 82.5 kilowatt hours. आता विचार करा, तुमच्या बॅटरी मध्ये किती होती? 18.5. तुमच्या घरातल्या UPS मध्ये किती होती? 2.3 or 2.4. आता आपल्याला जर 80 पाहिजे असेल, असे किती बॅटरीज लागतील? लेड ऍसिडचा. Lead acid typically it will be of this maybe 1.5 feet by 1 feet. So that will be the typical size. How many such you need? 82 divided by 2.4. First this. म्हणजे किती झालं? हे मोठं. याचं एवढं maybe this table. Full of this table. Will it work? No. Then what comes before us is, sir already talked about. Why do we need lithium ion? I mean, our friend also mentioned, right? So earlier there was lead acid battery, but they suggested you lithium ion battery. Maybe this is one of the reasons. Another is again a performance that also we are going to touch. Okay, now you got it, right? So what kind of battery do we need? We need a battery which has very compact energy storage, right? Right? So let's see what are the alternatives available with us. Okay, so just everything should be on your fingertips. जे काय बोलतोय किंवा मी तुम्हाला कोणीतरी बोलला असेल, you should be able to talk in terms of numbers, right? So this is that number. Okay, so you have a typical Tata Nexon EV. It has 38.5 or something, or maybe 40. Approximation certainly 40%. 40 kilowatt hours battery capacity, energy storage capacity. So how much is the range that you can expect? This template will be set. So we will this, right? So this is something that you should know, right? Good. This is okay. Pause. Now you know the battery that we need to use for your electric vehicle is something that has to have a very compact energy storage. So we talk about two numbers. Sir also mentioned, and even our previous speaker, Sir also mentioned. Ampere hours per watt hours per kg or ampere hours per kg, right? Power density and energy density. Who needs more power density? Either the Mahindra Evo or Tata Nexon? Tata Nexon. Power density, Mumbai or to Delhi, right? So energy density. Okay, so these are two concepts. Now we'll go for further. What are the parameters that decide our choice then? The range decides energy storage capacity and torque or the power requirement. It decides how your power is decided by the torque that you need for your vehicle. The picture this so these are the battery packs of your typical electric vehicles. Right? So काही इथले असतील, काही बाहेरचे असतील, so it's not mine. I am not going anywhere in the manufacturing facility. I have taken it from some sources, reports of mostly some reports and research articles. So going further, designing better batteries for vehicles. Obviously, we know the strategy now. We have to have the compactness into our technology. What are the options available for us? Right? So the options available. So this is Regoni plot. Okay, what is Regoni plot by the way? It's a bigger picture. So we have different technologies. So how to read this? कोणताही सायकलचा आपली कुठलाही ग्राफ रीड कसा करायचं? Y axis. Y axis is function. X axis is parameter. Function parameter. ठीक है, आपण function आणि parameter दोघे independent गोष्टी पकडल्या. So let's see what is on Y axis? Specific energy. Watt hours per kilogram. Energy, right? So this much energy. If we, would you like to go on higher side or lower side? Obviously, one would like to go for higher side because we need to have compactness into the storage space. Now, how about this specific part? So, will this only work? Because specific power, meaning watts per kilogram, will also be important. So, if something, for example, even we have a very large storage facility, but at the same time, if it is not able to deliver us, at the faster rates, it will not be useful at all. For example, we will have to remain with this Mahindra Evo itself. Okay, so nothing can help, but just a simple comparison between two vehicles, right? Alright, so we would like to have a trade-off which will be here only. Higher capacity as well as higher specific power as well. Right? Only by going this direction will not help us. And we have different technologies. For example, this is lithium-ion technology. This is nickel metal hydride. That was also one cell technology. Obviously, secondary cells, meaning rechargeable cells. Here, lead acid. They have limitations. They are very low. For example, up to maybe just 10, 50, 60 or something like that. 60 watt hours per kilogram. Right? And how about power? Again, at lower side. In comparison with your lithium-ion and other things. Capacitors. They have very low specific energy. I mean, energies, watt hours are, energy storage is much lower with them. But they can aim for our energy storage for the EV application. Right? And again the same. I think it's not very much different. Except some other specific technologies are mentioned in this review. Okay, so why is the better present day EV market dominated by lithium-ion? Now we already know the answer. We have seen in the previous part. Because they are, okay, so what we have at the moment is some specific energy and specific power. But at the same time, when we are comparing that with our say maybe technologies before lithium-ion battery and technologies that are beyond lithium-ion batteries. For technologies beyond lithium-ion batteries, there is little bit of uncertainty. People are not sure about their performance, about their reliability. Many other things are uncertain, right? And how about the robust technologies that are there before lithium-ion? For example, lead acid. It is there for 150 years. The technology is very much mature. But problem is what? We have experienced this much, and mind you that is one unit of 2.4 kilowatt hour requires weighs more than 65 kilos, and that many say 34, 39 will have that much weight, right? So to carry them itself is a challenge, right? So we have many problems. Therefore, and very similar case with nickel metal hydride. Nickel metal hydride is also a technology that was before lithium-ion technologies. But problem with them was the number of cycles that it can go for charge and discharge, right? So there are several problems that we have come across for this. Therefore, future looks bright for electric vehicles. Why? Because actually it's again divided to other 3-4 types of electric vehicles. Then first is the internal combustion engine, then hybrid vehicles, then fuel cell electric vehicle, plug-in hybrid, and battery electric vehicle. Obviously, all these 3-4 are supposed to be there for next say 50 years down the line, or not 50, if not 50, 20, 30 years down the line, those will be there. But people project that fuel cell based electric vehicles will be the preferred one. The reasons are several, because many nations have launched their missions for the hydrogen fuel, right? So hydrogen mission, even India also have launched it, right? Hydrogen mission is already launched by our Honorable Prime Minister in the last independent days, right? So we have, and many governments across the world have launched their hydrogen mission. And hydrogen is the fuel for the fuel cells. Therefore, that will be the technology. Maybe 10, 15 years down the line, that will be maturing to a better scenario. That was in the projection. Okay, so but at the moment, lithium-ion is leading the race. Right. So, summating cost of batteries. See, the cost of batteries have dropped drastically. This is data for 1991. So, the term pocket friendly has not come with this, right? So, at the moment it is pocket friendly, but earlier it was not, right? So, it was way too costly. When Samsung launched or Sony launched their first lithium-ion cell with our very beloved John Hoodina, right? So who won Nobel Prize for lithium-ion batteries, 2019, right? So that was the technology that was laid, and that has made the battery-based electric vehicles the forerunner for the promotion of the new technologies to avoid kind of emission, carbon dioxide emission, right? So the next is also very similar. Energy density is increasing at the same time. So this is what years are coming up. So these are the further numbers. So in this way, so that is so it's just one more way of plotting them, opposing them. The meaning is very similar to the previous one. Okay, so different form factors of, I think we need not mention. We have some cylindrical cells, some prismatic cells, some pouch cells. Sir have already covered most of the parts, and we need not. Okay, so how the growth has happened for electric vehicles? So here 2018, 20, 2030. The projection says that battery industry will have huge growth, right? So the global capacity, battery demand will increase to 2,500 gigawatt hours. What does this giga mean? Kilo is, we have seen already, kilo is 10 to the power 3, mega 10 to the power 6, giga is 10 to the power 9, right? Those many gigawatt hours. So one unit was 2.3 kilowatt hours, right? So, and that was costing, say, at the moment maybe 15,000, 16,000 for lead acid batteries. For lithium-ion batteries, it costs at least 2 to 3 times the present market. Just I am giving you numbers. How much is that? Mind probably number. So 2,500 gigawatt hours, and how much is the cost of every quarter, you can just now calculate. Go home and do the exercise. And what I am telling you is that there is huge number. Is many are the dollars in my view. Okay, so dollar is again higher in number. In comparison with rupee, it's already something like 3 or 8 days, right? Okay, so if not totally yours, you can certainly do it because there is opportunity for you, but just 0.1% of that you are able to capture that as a business. That will be useful. Okay, opportunity for you. If not, if someone is investing and building an industry, you can help them. You can certainly get jobs, right? So second opportunity. So what are other kind of okay, let's go back and visit our technology, understand our technologies. So electrochemical energy storage technologies, right? So we have many types, right? It's not again good point to visit that also. I'm just saving my time. So what's the time?
It's okay.
So we'll
Please.
yeah. So what time is it?
10, 15 minutes.
Okay. So I'll just go to the main gist that I would like to highlight, and then okay. So this is again this is very nice thing. At least if sir permits me a week itself, I'll be happy to interact with you people. Okay. So but I also invite you all to visit our Funde sir. Funde sir can also help you in that matter, or Ashish sir should. So what we have is like these are three types of, but we have seen their energy and capacity, right? Watt hours and ampere hour capacity. So we need not worry too much about it. We already have seen that. So these are three types of storage facilities: ultra capacitor, then super capacitor, then batteries and fuel cells, and their different capacities. आणि प्रत्येक एक नंबर म्हणजे तुम्हाला एक अपॉर्च्युनिटी, right? So if there is one material and that you would like to take it to the next level, maybe some marginal increase, if you are able to achieve, that itself is achievement. Maybe you can find patents. Sir told us that he find 26 patents. You also can take
At least one PhD.
Yeah, that one PhD is also okay. Right? So you align yourself. There is vast opportunity for you, right? So this is also one more takeaway message from this slide. Okay, if it is busy, it's good because there is a lot that you. Okay, it's not. I mean, something you can say that okay, much is already done, but it is equally true that much is yet to be done, right? Okay, so I'll not highlight anything of these chemistries. This is lithium-ion chemistry, which is the forerunner of your electric vehicle battery technologies. And how does it shuttle, lithium-ion shuttle from this cathode to anode, anode to cathode? It's under some, maybe sir will always help you to understand that. And Mr. Google is already with us. And it's not a joke actually. So nowadays you have many means and ways to learn things, right? So what is on your finger, rather in your palm? So instead of just playing something else, if we are able to gather something which is knowledge or some enhancement into your knowledge, that will be helpful. Okay, please go for it. We have PDX as MOOCs, maximum online open courses. Many of them, Udemy, and many courses are free for you, right? And of course, NPTEL and many others are. So improve yourself every time. Okay, so again, busy slide. But what is important to highlight is this. So I was talking about watt hours per kilogram, specific energy and specific power. These are two or rather, and third is equally important, right? How many cycles will it last? So So how many years, how much is the warranty of your batteries, right? So that will decide how much are the number of cycles that we can sustain, right? So these three are important for you. I'm going to share this set of slides with you. So you please go through them. You will certainly know that this is the number, which is the just 2 seconds. 400, you can find, obviously. That's why it is 400. Obviously, for other numbers as well. And I was talking about lead acid batteries. So lead acid batteries, 30 to 50 kilowatt. It's small number in comparison with that. Nickel cadmium, 35 to 80 watt-hours per kilowatt. And SP power was much better in comparison with that. But it's very similar to your lead acid batteries. But for your lead acid or lithium ion batteries, it's very nice scenario, right? Because it can go up to 450. Obviously, it's a theoretical capacity, but practical cells are already at 200 watt, right? Therefore, it is the technology to be supported here and at the moment. But let me go further. So beyond, so the technologies before lithium, I just now talked about that. Right? Lead acid batteries and nickel cadmium batteries. Lithium metal is also something. Primarily it was primary battery. Primary means non-rechargeable. Secondary means rechargeable. Let's talk about lithium ion batteries, which is mainstream. Okay. In case of metals, lithium metals. Obviously, this is a evolution how batteries evolved throughout the time. 1866, 1859 was the first liquid battery that was reported by McLaren. 1859. So 1839 was the first battery. I'm sorry. 1859 first lead acid battery, commercial lead acid battery, and the evolution took place. And lithium came into picture. Directly jumped into this, and let's continue over. So this is the totally lithium battery evolution. It started with 1991, or just little before that, and then at the moment it is the only forerunner battery technology. But nowadays we also come across many other talks that this is very similar to new Middle East, right? So earlier we are comparing crude oil from Middle East countries or the countries wherever the crude oil is there. But for lithium, India as a nation, we do not have any resources of lithium, right? And lithium is just 3% of that whole battery mass. Other components or elements are mainly cobalt, iron, and lead. So that's why most of the time in India, let's prefer the iron base, LiFePO, right? Phosphorus and all these elements are there. And lithium as an elemental mass is just 3% of whole mass battery, right? So there are again pros cons, and we are just going at a level, and that's how we are evolving. But okay, so that can be another point of discussion. So this is how it has evolved, and this is now a forerunner. Okay, so lead acid batteries, nickel cadmium batteries, nickel metal hydride batteries, but lithium ion that now will be here. So another means of lithium ion batteries are lithium sulfur. Lithium sulfur, many other chemistries are there. Lithium metal also, and several other evolutions have taken place for lithium technologies, right? So people are involved. Specific energy and specific density, both are involved. So pros and cons. So what is this? Again, another good plot. What are these parameters? Every axis is different parameters. We have plotted several parameters for different technologies or cathode materials. In case of lithium ions, I just now mentioned that cathode materials are important. Anode, it's graphite only most of the time, right? There can be minute modifications, but in this graphite, it is fixed most of the time. But for anode, we have different materials, and all these different materials have different advantages or disadvantages. Advantages will be on the higher side, disadvantage it is on the lower side. Okay. It starts with this origin. Let's go over here. Let's compare lithium manganese oxide, lithium cobalt oxide. So if it is lithium cobalt oxide, what it lacks is just lower power density, for example. So this is how we read these laws, right? And let me go to this. Why it is important? Because it talks about anode material, very similar to cathode material, right? So these are the anode materials. What we have is lithium metal. If it is lithium metal, then we have graphite also. Graphite has much of this as advantages because it's a low cost metal and it's a byproduct running some of our ores or mines of the core, right? So therefore it is advantageous. And when we talk about lithium metal, it's advantageous in some cases, but it is very much disadvantageous. For example, in some cases, let's say safety, it is very poor in terms of safety, right? Because it can lead to many hazards that may be leading to accidents. Okay, so beyond lithium, these are metal layer batteries, sodium beta batteries, alternate batteries. Then emerging battery technologies are also there. All these are opportunities for you. So since there is no forerunner beyond lithium, many things are to be evolved, and these are some of the technologies where much of research is needed. Then other promising technologies, then these are the real carbon batteries or many other things. Now, so is the storage required only at the electric vehicles? No. Because you I think I have to do this. That's right. Let me show this. So this slide says that the highest all India demand of electricity that we are running to our wires, highest demand was noted to be how many? Zeros. It's in megawatts, right? Let's calculate in gigawatts. 200.57 gigawatts. So it's power, by the way. It's that much power consumed by every load connected to the electric grid in India, right? It's huge number. So, and India as a nation, as we just now mentioned, that we are using most of the time coal as fuel for electricity generation, right? Almost 61% electricity is coming from coal, right? And this demand is ever increasing, right? Because our population is increasing, our aspirations are increasing, right? So many things are increasing. Therefore, energy demand is going to increase. So we need to shift sources which are renewable, for example, solar energy, for example, wind energy, and they are very intermittent in their. For example, there was complete cloud coverage for last 15 days, right? So during that time, even if we have installed 2000 megawatts of capacity in Pune, it would have hardly generated just 40% of the installed capacity, right? So in order to match the demand, and I have not brought that, but our India's demand rises something like this. For example, at 4 a.m. in the morning, the demand is the lowest one. For example, number, let's say 100. From 100, it goes to suddenly in the morning at 6 o'clock, or 6 to 7 or to 8 o'clock. The demand rises to 85. Noon time it reaches little, but in the evening it at 6, between 6 to 7 p.m. it rises again sharply to 130. From 100 to 130, 30% increase. So we should be able to manage that demand. On the top of that, we are introducing very intermittent sources of energy. For example, wind and solar. So in order to manage that grid, load demand or the demand side management, we need to have storage system of electric electricity, right? So there are many things, friends, we can talk about, and we need to work on it, right? So some of them are something like this. So let's start with this. We have started because it is already pocket energy. The electric vehicles, right? The electric vehicles, if we are working with them, we can have vehicle to grid connection. What I am talking about is something like, for example, you already might be knowing that our household electricity is charged at a flat rate. For example, something whatever is the rate that we are incurring at is something like 10 rupees a kilowatt hour. But for industry and larger demands, the rate is differential. For example, there are time zones: A zone, B zone, C zone. Right? For example, I just now mentioned morning 6 to 10, the charges are different. At night time, the demand is less. So they encourage you to consume power during that time. So you will be charged less than the flat rate. If you consume during peak hours, you will be charged more. You try to reduce your demand from that side. So these are some measures, right? Now what I am talking about is, for example, there will be an exchange, power exchange, very similar to your, so you have electric vehicle, you have 40 kilowatt hours, 40 units load in your vehicle. If they ask you, okay, they declare, right? The power exchange will declare. If someone pumps in power into grid at this point of time, we will pay them 20 rupees per kilowatt hour. Obviously, we have 20 rupees, but if you are selling it at 20 rupees, obviously you will be jumped to pump it, right? So that will be vehicle to grid. So this is that kind of thing. Why I have used you? Because if it is pocket friendly, then we will go for it. So something like, even if it is 1 rupees as an advantage, and for grid operators, if this becomes an advantage, that will be the vehicle to grid. So this is one vertical that may come up. Then vehicle to home. Obviously, at home there is power outage. Or you want to reduce. For example, there is a huge power charges at maybe 6 to 7 p.m. in the evening. They charge us differential, right? Say they charge us at 20 rupees a kilowatt hour. That time what will you do? I'll just turn off power from utility and I'll pump in power from my electric vehicle. That is also possible. Artificial intelligence, all these things, right? Exchanges, how much is the energy required, at what rate it should be charged, and many things. It will require many other learnings as well, right? Artificial intelligence, energy router. So where should it go? For example, we have say 1,000 facilities, like Fergusson College itself. We have Pune University. Fergusson College has maybe 1 megawatt of connected load. I think it should be the case. Pune University is 2.5 megawatt. We have another facility, households 3 kilowatt, 2 kilowatt or something like that. All these are to be managed. Who will be demanding at what rate? That also can be very much power routing kind of systems will be required. Then data energy sharing. Okay, so everything. So we have facility. Okay, so in this hall itself, in this very hall, each and every components are connected to electricity. But at what rate they are drawing power, if it is known to us, we can monitor. I mean, how should it be monitored, right? So all these things are there. Regular energy networks. within vehicles, for example, you see many OC bike riders, heavy, noisy bike riders. So they have something like this. Okay, so they have some network. For example, it is just personal connection in that case. But in our case, if it is energy sharing, that also is possible, right? So many things are possible because of this new technology. So there are many opportunities for your viewers. Just learn something about it. And I told you that it's not like necessary nowadays. And we are living in good era where kind of we are able to switch between knowledge sources. We find something. For example, at the moment I am domain expert of something else. I can certainly have an opportunity to interact with sir and gain knowledge for some other topic. So they may open for your exchanges. Sorry, I will run to my advertisement. What we are doing at the moment in our laboratory, there are some techniques and some list of students, some projects that they are handling, and some results that I do not have time to go through. It was just advertisement actually, and this is that small group that we have in our laboratory. You are all welcome to us. And summary, there is a lot that we can explore. Just how it is not sufficient. Alright. Okay, so go anywhere. Everywhere is free of cost most of the time. There is a lot to explore. So these are some websites where you can earn your knowledge.
That is more important.
Yeah.
Students.
What can I contribute? I posed this question in the very beginning, right?
Please.
So, I think there is certainly something that you can. Okay.
Thank you.
Thank you.
Session is open for question answers, discussion.
Yes. I'll be happy to find questions.
Why there is no development in fuel cells? Like it's very eco-friendly, abundance of hydrogen, oxygen, everything is there, but then why?
I will just mention the specifics. Okay. So what is fuel cell? We have hydrogen, and on one side of the separator, there is a membrane, right? So membrane has to allow the exchange of ions and not the electrons and electrons. So on another side we have oxygen. But this membrane itself, if you you'll be surprised to know that maybe for 13 centimeter by 13 centimeters of membrane costs something like 1 lakh rupees. And why it is coming into picture? That the material itself, right? Beyond that, it gets blocked in the exchange